Hi, am I audible to all of you? Good morning, good afternoon, good evening, and greetings of the day. I hope you all are doing well, and I'm hoping that I'm clearly audible to all of you. And yeah, welcome back to the session. So, in the session yesterday, we spoke about some amazing concepts. We tried implementing, first of all, we tried understanding unknown unicast flooding. Then we looked at how we can implement routing between two different networks by connecting them to the router and providing the default gateway IP address. Then later in the session, we also looked at how DHCP can be used. I have shared a lab guide yesterday for the DHCP configs. I'm hoping that you guys are practicing with me so that we all can get the best out of this CCNA training, right? Now, the session today is going to help you understand some more amazing technologies, out of which the very first one that I'm going to talk about is Telnet. Are you guys aware what is Telnet? Okay, what is Telnet used for? Let me know in the chat. It is used for managing or logging into the router from a remote device, correct? Right, for remote access. Perfect. Assume that this is your router in your server room, okay? And there are multiple switches connected to your router. You have one switch here, another switch here, and another switch here. There are some end devices connected to the router like this. Some end devices connected to the switch here and then here. Yeah. Now assume that you want to manage this router, router number one. So the very first option of that is you get near the router number one, you take the console cable, right? And you insert it into the console port of the router. You connect a laptop and then you can use terminal applications for taking access of the CLI of router. Yesterday, I told you a name of one of the terminal application. Putty it is, right? So you can open Putty on your laptop and you will be able to access or manage the CLI of router from your laptop. But there are possibilities that I might want to access router one's CLI sitting directly from this PC here, right? When I am here connected on the, let's say this team is the network engineers team, okay? So what I want to do is I don't want to walk up into the server room and then connect a console cable. I directly want to access and manage router from this PC. So this type of connectivity is called remote connection. And remote connectivity can be provided using two protocols, Telnet or SSH. So we will learn both of these today in the session. We'll try understanding how these can be implemented on a router. But if I give you a quick differentiation between Telnet and SSH, then we can say Telnet compared to SSH is less secure, whereas SSH is secure. Okay. Why do we call Telnet less secure? Because data here travels in a clear text form. So if you have sent some configuration over a Telnet connection, or if let's say you are fetching out some details from the router over a Telnet connection, then it's going to be traveling over the cables in a clear text form. Anyone who captures that packet will be able to read that data. In the case of SSH, that data is encrypted. Okay, so an encrypted data can't be understood. That's another difference which we have between Telnet and SSH, and that's why we call Telnet less secure and SSH more secure. Then, perfect. Someone has mentioned the port numbers. The port number on which telnet connections are established, it is 23, and the port number on which SSH connections are established are 22. I'll put it nicely so that you guys can understand when you read it later. Here we have telnet, here we have SSH. This is less secure. This is more secure. Then the port number used by telnet is 23 and the port used by SSH is 22. Here the data travels in a clear text form, and in SSH it uses encryption. It encrypts the data so that no one who tries to capture it can read that information. SSH stands for secure shell. So first we will learn how to configure telnet in a small topology, and then we will learn how to implement SSH over it. I'm going to share my packet tracer window, and let's quickly see the configuration of telnet and SSH. Okay, I hope my screen is visible to all of you. All right, perfect. So what I'll do is I'll take a simple small topology here. I'll take one router and I will connect one switch and some end devices like this. Let's connect them together using a cable, PC0 to switch and then to the router. Now I want to connect all these devices under the network 192.168.100.0/24. Okay. For which I will configure my router with DHCP. So first thing that I need to do is I need to put IP on FA00. What IP shall I configure on FA00? Let me know in the chat. 192.168.100.1, as that is a usual practice. So I'll say enable configure terminal config T host name R1, and then on the interface FA0/0, I will put the IP address as 192.168.100.1/24. No shutdown and exit. After that, I need to create DHCP pool for my network 100.0, right? So I'll say IP DHCP pool A for my network 192.168.100.255.255.255.0 with a default router address 192.168.1. Okay, I made a mistake, guys. I have given the network ID incorrectly. So let me fix that. I'll say no network 192.168.1.100.255.255.255.0. When you add no before the command, you basically remove that command from the CLI or from the configurations of the router. Okay. So now after removing it, I will add a new command, network 192.168 100.0 255.255.255.0 with a default router address as 192.168.100.1. Exit. Any questions or doubts so far? Perfect. So I'll go to the end devices. I'll provide them IP using DHCP. I'll click on DHCP. Let's see. Okay, DHCP got failed. I'll try again. It's again failing. There must be some problem in the configs. But every time DHCP will fail, an APIPA IP address is assigned to the PC. This IP is self-generated by the PC, and APIPA stands for Automatic Private IP Addressing. Okay, so every time your DHCP is going to get failed, your PC will generate an automatic IP, and that IP is not routable. That means you cannot use it for making communications. But yeah, some random or we can say some self-generated IP is going to get assigned on the PC. So let's try to figure out if we have made some mistake. Interface FA00, 192.168.100.1, 255.255.255.0, no shutdown. Then IP DHCP pool A, network 192.168.100.0, 255.255.255.0, default router address 192.168.100.1. I will check my DHCP configs using the command show running config pipe section DHCP. Okay. Now, since we have used this show command, let's talk about running configuration. Running configuration is the is the temporary configuration which stays on the router. If I turn my router off right now, my running configuration will get removed. If you can recall, when we spoke about switches, we discussed that there is a memory called RAM, right? Inside the RAM, we store running configurations. And because RAM is a temporary memory, so if I shut down my router and I boot it again, all my configs will go away. So to save these configurations permanently on the device, we copy the running configuration into startup configuration. And startup configuration is saved inside NVRAM, which is a permanent memory. So right now, when I ran this command, what I exactly wanted my router to do is from the whole running configuration, I wanted just the section which defines DHCP. So the moment I executed this command, it gave me the DHCP section of my running configuration, which contains basically these two commands. And if we look at these commands, the commands are pretty much accurate. So we don't have any problem in that. I'll just check my IP configurations also by running show IP interface brief. I can see FA00 is there, 192.168.100.1 interface is also up. So everything looks fine to me. I will try again. I'll go to the PC again. We'll try for DHCP again. It's still failing. So can be a packet tracer bug also. Let's do one thing. Let's restart my router. But guys, if I restart my router, this IP configuration or the DHCP configuration will go away because I have not saved it for me, right? So to save this, like I said, we have to copy the running configuration into startup configuration. I'll hit the enter button. It confirms the destination file name and then says OK. Now this configuration, the temporary configuration is saved permanently inside something called as NVRAM, non-volatile RAM. So NVRAM is a permanent storage. That means even if I reboot my device, the IP configs and the DHCP configs will still be there because I copied it into startup config. Make sense? Now, after saving my configuration, I can simply reboot the device. So I'll say reload, enter, confirm. My router is up again. We can see the host name is there. If I check show IP interface brief, IP configs are also there. If I check show run pipe section DHCP, I can see DHCP configs are still there after I have reloaded my device, right? So I'll go to the PC1, let's say this time. And once this interface turns up, I will try DHCP. Yeah, it's up now. So I'll go to the IP configs, DHCP. Here it is successful now. So possibly it was simply a bug. Yeah, we got the IP here also. Then on the final PC, I'll try DHCP. And yeah, it is successful. After reloading the device with the same configuration, my DHCP worked out. So that's a usual and often scenario that you might face with packet tracer. As it is just a simulator, sometimes it troubles you. So all you can do to fix it up is either try to reload the devices or try to create a fresh new lab. So yeah, I created my range starting from 190 to 168.100.0 for the whole network 255.255.255.0. So it will include the complete range from 100.1 to 100.255. Make sense? We need not to define the end range. Okay, moving ahead, let's configure telnet on my router because telnet will allow me to access the router from this PC0, PC1 and PC2. Okay, yes, very correct. We can use copy. So for saving the configuration, either you can say copy running config, startup config, this command, or otherwise you can use write memory. This also does the same job. So for permanently saving your configurations, you can use write memory or copy running config. Or as a shortcut, you can use WR. That will also do the same thing. Now, let's focus at understanding how telnet can be configured. For configuring telnet, we use something called as virtual lines. And virtual lines can be configured using the command line VTY question mark. I have to specify first line number. So for example, if I want to create 5 lines, so I'll specify my first line number as 0. Again, if I hit the question mark, now it is asking for last line number. So I'll say the last line number is going to be 4. So line VTY 0 space 4 will create 5 virtual lines, which can be used for establishing telnet connection with the connected router. So 5 people at a given point of time can take telnet access of my router because I have created how many virtual lines? 5. And how many maximum can I create on this router? 0 to 15. That means in total 16 lines. Okay. Right now we have created 5 line VDY 0 space 4. Yes, correct. 0, 1, 2, 3, 4. These are 5 lines, right? After that, I'm going to set a password for this. Password Cisco. Then login, which I'll use basically for signing in to the virtual lines, login, and then exit. Along with that, we will use enable password. Enable, and I'll put a enable password also as Cisco. Sorry, enable password Cisco. This first password that I gave as Cisco is going to be used for taking telnet access of my router. So when I will log in using telnet, I will have to put this password. Okay, that's my authentication for telnet. After that, enable password is used when my user wants to enter into the enable mode. So when they have taken access over telnet, after that, if they wish to enter into the enable mode, they will have to enter this new password to get the access of enable mode. Okay. So from my PC0, I'll go to my command prompt and I will try to check reachability first of all with my gateway, which is 192.168.100.1. And as we can see, we are getting the replies. The reachability is there. After that, I will try telnet. So telnet space 192.168.100.1. You see, it is asking for a password. First of all, I need to use Cisco, which is my login password. Enter. When I do so, I land into which mode, guys? Which mode of CLI is this? User mode, right? I will try to get into the enable mode, for which I'll enter the command enable. And when I do so, it is asking again for a password. This is my enable mode password. So I will type down Cisco again, enter, and there you go. We are inside the enable mode. Make sense, guys? You can see we are accessing the router 0's CLI from PC0 using telnet connection. So this is how you remotely manage your device. You can run the show command here, show IP interface brief, and you can see what's going on the router. So if you are a network engineer, you don't really have to get into the server room and put a console cable and then maybe take the access. No, that is not required. You can directly take the access by using remote connectivity protocol like Telnet. Any questions or doubts in this? I'm sharing a lab guide for you all. Please try out the same configuration and let me know once you are done. From pool, it will take any random IP or in any sequence for all three PCs. Ankush, usually it is going to take in sequence, but it is not necessary. It can also pick up random IP addresses. Guys, if you will click on the group name, like on your whatever device you are using Telegram, if you click on the group name, you will see a section called media. If you go there, you will see the images that we post in this group. Right next to it, there is a section called files where you can see all the PDFs that I have shared. So from there, you can check out the previous shared lab guide, which was for DHCP. Sayed, right now we are just using one line. We are not using four. If you see the telnet connection, I have only established from PC0 to router 1, right? So there is only one line which is used so far. If I take access on PC1, PC2, PC3, PC4, and then let's say try the sixth PC, then it is going to fail. Max limit is 5 PCs. As I have created line 0 to 4, that means 5 lines. So 5 PCs can connect at a time. Usernames can also be configured. We'll talk about all those things gradually, guys. I want you to try this much first, then we'll speak about the other things as well. Try this, and then we will move ahead. We'll look at how usernames and passwords can be used for signing in. Yeah, this configuration that we have looked at is for Telnet. So for SSH, there is different configs that we are going to try. So yeah, quickly try this, then we'll move to SSH. We have given 2 times the password Cisco. The first one is for logging in. This is the line VTY password. And the second password is for getting inside enable mode. They both can be different. For the simplicity, I have used Cisco both the times. But yeah, these can be different. Noor, we use Telnet in real world when the connectivity is completely private. Like if let's say you are connecting within your organization, within your corporate small network, then you can go for Telnet. Otherwise, if it is something which is going to include internet or let's say some public network, then we go for SSH. Yep. Support numbers are used for differentiating between protocols. When you are building connections, it is the port number which will tell network devices for what protocol this connectivity is being established. So the telnet uses port number 23 and SSH uses the port number 22. No, Saurabh, the PC can be in a different network also, but yeah, the reachability should be there. So if it is in a different network, we'll need routing to make them communicate, but they'll be able to telnet. Yes, the putty application is something that we use for connecting to the devices. So it gives you the option of selecting which protocol you want to use, telnet, SSH, and what port number you want to build the connection on. Perfect. Good job, guys. Those who have completed it. Those who are still working on it, 5 more minutes. Let's try to complete it and then move to the next discussion. All right, let's look ahead. Now, there are two things here that I really want you guys to look at. If I go to my router and I check my running configuration, so enable, first of all, will require a password. I'll type down the enable password, which is Cisco, and then I'll check show running config, enter. When I say show running config, I can clearly see the password is Cisco, correct? Similarly, if I look forward in the configuration, if I look down on line VTY 0 space 4 also the password is Cisco, I can read that clearly. This is quite insecure, right? This is not a healthy way of putting a password because anyone who will look into the running configuration will get to know what is the login password for line VTYs and for the enable mode. So what we do is we encrypt these passwords by using a command which you must have used in the PDF or the lab guide that I shared, which is service password encryption. So this command service password encryption is going to encrypt all the passwords inside my configuration. After executing this command, if I recheck my running configuration, so we can see my first of all enable password got encrypted, right? Similarly, if I look down into the running configuration, line VTY 0 space 4 login password also got encrypted. Make sense? So both of my passwords are now encrypted. If anyone would look at them, they'll not be able to understand what exactly the password is. Another thing is enable secret password. Now, as the name defines, this password is going to be secret. It is encrypted by default. So if you configure enable secret password, let's say enable secret, and I will put the password as PyNet @ 123. And I will check my running configuration again, show running config. So you see the enable secret password automatically gets encrypted even without the need of service password encryption command. So even if you are not using service password encryption, then also this password, the enable secret password will get encrypted. Another important thing here to understand is that now I have enable secret password and I have the normal enable password both configured on my device. So if I take exit from my enable mode and try to enter back again, which password should I be using? The normal enable password or the enable secret password? What do you think? It's going to be the secret password. So enable secret password is considered more secure than normal enable password. That's why when you have to enter back into the enable mode, Cisco is not going to work. You will have to type down PyNet @123, which is my enable secret password. So I'll click on my CLI and I'll type down PyNet @123. And there you go. I get the access of my enable mode. Then lastly, if I check show startup config, my startup config do not contain any password here. You see, there is no enable password. There is no enable secret password. Neither my line VTY is configured with a password or a configuration. Can you guys tell me why my startup config doesn't shows anything? Exactly, because we haven't saved any configurations. So after I have made the change, I didn't save it again, right? That's why I see those changes in my running configuration, which is the temporary configuration. I can see the passwords there. But when I check my startup config, which is the permanent config, I do not see it there. So how do we save it? What is the command for saving this? Copy run config to startup config. After that, if I check show startup config, I can see my passwords being copied from running configuration. Now these are permanent. That means even if I shut down my router and start it again, then also when the router will boot up, I will find everything there on the router configured. Let me know if there is any questions or doubts. Yeah, that's correct. Write memory will also work. These are the alternative commands. You can use any of them. Secret password चाहिए this for the enable mode. It's not for your telnet connection. Telnet connection password is a different password. Secret password is not for your user mode. It's for the only enable mode. Yeah, because the name itself, if you look at the command, it is enable secret, right? The command is enable secret. So it's basically a password we are using for enable mode. Sure, I can go with the majority. If all of you think we are going a little fast, then I can definitely slow down. But my aim is to teach you as much as I can in the defined number of days. So that's the reason why I try to, speed up sometimes and explain you the protocol so that we all can get the best out of the training. If it is getting too fast and you guys are not able to understand, then let me know. I'll slow down a little. Definitely. So yeah, I'll definitely consider your request, Lion, and I also request you all basically to try practicing what we discuss in the training so that you guys can get a good hold of it. As you mentioned, it is quite really important for you all to understand the fundamentals well. Keeping that in mind, let's talk something about static routing today. I will introduce you to routing now. Let's understand why routing is required, in which situations it is required. Sharing my other screen. All right. So now we are going to speak about something really, really important, which is routing. The question is, where do we require routing? Routing is used for connecting different networks together. In our session earlier, we tried connecting two different networks together. R1 was connected with one switch and another switch. There were N devices connected to switch 1 under the network 192.168.1.0/24, and there were also N devices connected to switch 2 on the network 192.168.2.0/24. And using the default gateway, guys, I'm hoping my screen is visible to all of you. Yeah, Mohini, if you are facing issues, please rejoin. Don't worry, Sanju. I'll talk about these protocols later. As of now, if I'll speak about SSH, you will get confused with Telnet also. So I have done that intentionally. I wanted just you guys to know that along with Telnet, there is also an option called SSH. Later on, we will understand how to configure it. Don't worry about it. Yeah. Okay. So basically, I was saying that we tried connecting them together using a router. So does that mean we implemented routing in this situation? Definitely yes. It is routing only which lets the router 1 forward the traffic from 192.168.1.0 to 192.168.2.0. But the question is how it does that. R1 was configured with two IP addresses, one here 192.168.1.1, and on the other side we added the IP 192.168.2.1, correct? So all these layer 3 devices which are there for connecting different networks together, they maintain a table called a routing table. And routing table contains all the best routes which can be used for reaching a destination. Okay. In my case, R1 is connected to two networks, correct? So I will add information about these two networks in my routing table. Let's assume this interface is 0/1 and this one is 0/2. So in my routing table, I will add my information that there is a network 192.168.1.0/24, which is connected to me on the interface 0/1. Then another entry will be there that there is a network 192.168.2.0/24, which is connected to me on the interface 0/2. This is how routing table will be maintained for these two connected networks. Okay. Now what happens when my PC generates some traffic from this side to this side? A packet is generated on which there is going to be a source IP, there's going to be a destination IP, there is going to be source MAC, there is going to be destination MAC. Understanding this part is really, really important. So I really request all of you to stop messaging for some time on the group. Try to rejoin if screen is not visible and pay your attention completely on the topic. Okay. So we have discussed that I want to send traffic from this PC to this PC. Now assume that IP of my first PC is 1.10 and the MAC address of my PC is AA. Then IP of my second PC where I want to send the traffic is 2.10 and the MAC address is BB for router and CC for PC. You guys tell me on the packet, what value shall I add for source IP address? What should be my source IP address? IP of my PCA, correct? Which is 192.168.1.10. So I will type down my source IP will be 192.168.1.10. What's going to be my destination IP? Two dot 10. So 192.168.2.10. What will be the source MAC address? AA. What will be the destination MAC address? Some of you said BB, some of you said CC. Let's try to figure out. My destination MAC address will be BB. Let's understand what happens when we send traffic to a different network. When I see that my IP or my destination is in a different network, I will give this packet to my default gateway, correct? Default gateway or the router is the device that takes me to a different network. So my first hop will be router number 1. That's why my destination MAC on the packet will be BB. And how will I learn this destination MAC? Using the ARP protocol. Perfect. Now, basically, we can say my packet will move from this PC to the router. Okay. Router is going to check the information on the packet and it will find out that, okay, I am not the destination of the packet. Why am I not the destination? Because the IP mentioned on the packet is 192.168.2.10. Correct? So router will go into the routing table, will try to find out, is there any route for reaching 192.168.2.10? It will know that the network 192.168.2.0 is connected on 0/2 interface, right? So that means the 2.10 device must be connected to me over here. Now what I will do is I will remove the layer 2 information and I will add new information as per which the data will travel from R1 to PCB. So now the source MAC will be changed to double B and my destination MAC will be changed to double C. Then this packet will travel from R1 to this particular PC. This is how the communication happens. Throughout your journey or throughout your communication, the source IP and destination IP will remain the same, but the destination MAC and the source MAC will be changed on every hop. Rahim, we will not consider destination IP as router's IP because that's not the final destination I am trying to reach, right? I eventually try to reach this PC. But for layer 2, if you remember, I have told you guys, communication happen from one hop to the other hop. So that's why first my PC A will give it to the router, then router will check the routing table and will forward it from router 1 to this PC. Now switch is not playing any role in this because it's a layer 2 device. It is simply there to forward traffic from PC to the router. It has no job of performing any sort of forwarding here. This communication is happening on layer 3, right? So switch is not going to play any role in that. Okay, moving ahead. Now we will consider a different topology. Let's say I have two routers this time, R1 and R2. So on R1, I have a LAN network connected to me, having some end devices connected to it. On the network 210.1.0. On R2, I have similarly a network connected to me 210.2.0. So if I talk about the routing table of R1, there I'll have a connected route 210.1.0/24 and whatever is the interface, let's say 0/1. So it will tell me that it is connected through 0/1. Correct? Similarly, a routing table of R2 will be there where there is going to be information about the connected route 210.2.0/24 and the interface connected to it is 0/1. Clear, guys? Then let's say I make a connectivity between R1 and R2 also, and I connect them using the network 210.3.0. So in my routing table, another route information will be added, which is 3.0/24, which can be connected to me on 0/2. Right? Similarly on R2 also, I'll have the same network connected to me 3.0 on 0/2. Any questions so far? No questions? Perfect. We are all clear so far, right? But if I want these devices to communicate with these devices, I need something called as routing. Routing would be required to make R1 learn about this network and to make R2 learn about this network. By default, my routers will only learn about their directly connected networks, right? Like R1 learned about 210.1.0 and 3.0. Similarly, R2 only learned about 210.2.0 and 3.0. R1 will not automatically learn about its indirectly connected network, which is 210.2.0. For making it learn about this network, we need what? We need routing. Clear, guys? Now, routing can be configured in two methods. You can configure routing statically, which is called static routing, or you can configure it dynamically, which is called dynamic routing. Static routing means you specify manually that these are the routes that I wish to add. For example, in this case, on R1, you will configure this route manually. You will tell R1 that, hey, R1, I am giving you a static information to reach the network 210.2.0/24. You can give the traffic to router number 2. This is how you add the route. Okay. Similarly, on R3, on R2's routing table, you will add a static information saying, hey, R2, to reach the network 210.1.0/24, give your traffic to router number 1. This is how you add it statically. In dynamic process, this exchange of information happens automatically. You don't have to do it. It happens through a protocol. So what are the protocols there? Let's talk about them also. There are again two types of protocols. IGP, which stands for Internal Gateway Protocol. And EGP, which stands for External Gateway Protocol. Internal Gateway Protocol includes protocol like RIP, like EIGRP, like OSPF. Now, what is RIP? What is EIGRP? What is OSPF? We'll speak about all these things later on. But for external gateway protocol, there is only one option, which is BGP, Border Gateway Protocol. In CCNA, we will learn these three. We'll not speak about BGP. We discussed that in CCNP. So that's not our topic. In the official syllabus, you even will not find RIP and EIGRP. But at PyNet Labs, we understand that these are pretty important concepts. So we will definitely be speaking about these as well. Okay. Today, our focus is on understanding static routing. So let's create a topology and figure out how static routing can be configured. Chetan, like I said, it's not a part of CCNA. That's why I will not be speaking about it. Now, in this small setup, I need to tell R1 about this network, right? And similarly, R2 about this network. So I will create a similar topology on packet tracer, and let's try to configure static routing between them to make this PC communicate with this one. Let's see how we can implement that. My screen should be visible again. And like I said, I will create that small topology. I'll take my router number 1 here, router number 2 here. Then I'll add two switches. This is switch 1. This is switch 2. Then I will connect some end devices, PC1, PC2, PC3, PC4, like this. Connect these devices together like this. And once the connection is established, we are good to proceed. The network that I'm going to use for these devices is 210.1.0/24. For the network connected to R2, I'll use 210.2.0/24. And between R1 and R2, I will use 210.3.0/24. So first of all, I have to configure IP addresses on all the devices and DHCP pools for this network and this network. Correct? I'll go to my router number 1, CLI, say no to the question, enable configure terminal, host name R1. On the interface FA0/0, let me know what IP should I configure. Pooja, DHCP is not a routing protocol. It's for assigning IP addresses. So because FA0/0 is connected to my switch, which is connected to 210.1.0 network, I will configure it with the IP address 210.1.1, 255.255.255.0. Then I will say no shutdown, exit. On FA0/1, what IP should I configure? Can I say 210.3.1? I'll go to interface FA0/1 and there I'm going to set the IP 210.3.1/24. No shutdown, exit. Then let's create DHCP pool for my network 210.1.0. IP DHCP pool A for the network 210.1.0, 255.255.255.0 with a gateway address as 210.1.1. Exit. Next, I will go to my router number 2. On the router 2 also, first thing I'll do is I'll configure IP addresses. So enable config T host name router 2. On the interface FA0/0, which is connecting to router number 1, I will use the IP from subnet 210.3.0. But because 3.1 is already assigned on router number 1, on router 2, I will configure 3.2. So IP address 210.3.2/24. No shutdown, exit. Then I will enter into the interface FA0/1, where I will configure the IP address as 210.2.1/24. No shutdown, exit. Finally, I will create a DHCP pool for this network. So IP DHCP pool A network 210.2.0/24 with a gateway address as 2.1. And we are done with basic IP and DHCP configs. I will go to my end devices and will start providing IP address to them. So desktop, IP configs, DHCP. IP is assigned, subnet is assigned, gateway is assigned. Next PC, desktop, IP, DHCP. There you go. Desktop, IP, DHCP. Clear, guys? Now my job is to make R1 learn about this network and R2 learn about this network. As of now, if I go to my R1 and I check my routing table, so I can check that by saying show IP route. Show IP route command prints out the routing table. When I check that, what do we see? We see only two connected networks, right? 210.1.0, 210.3.0, like we discussed on the notepad. Similarly, if I go to router 2 and check my routing table there using the command show IP route, I see 210.2.0 and 210.3.0, correct? So it is my responsibility to make them learn about their indirectly connected networks. So I'll go to my router number 1. I'll get into my configuration mode and I will use the command IP route space 210.2.0 with a subnet mask of 255.255.255.0 can be reached through my router 2. Router 2. But I cannot tell my router to basically look for the name router 2, right? So what do we use instead of name? What do we use in the networking industry? We use IP addresses. Like we humans use names. In the case of computers, it is IP address, correct? So I will tell that to reach 210.2.0, 255.255.255.0 network, you have to give the traffic to router 2, which is basically reachable on IP address 210.3.2. And this device will be called as next hop. From PC, if I want to send a traffic to PC5, PC3 will give it to router, router will give it to the router 2, right? And router 2 will give it to the PC5. Now PC5 also will give a reply back to PC3. So PC5 will give it to the router. But does router know how to reach 210.1.0? Does the router 2 is aware of the network 210.1.0? No, right? So I'll not be able to give a reply. So for that, we will configure a static route here as well. I'll say IP route 210.1.0, 255.255.255.0 via router 1. What is IP of router 1? 210.3.1. Are we clear about this? Now I'll go to my router 1 and I will recheck my routing table. So exit, show IP route. Along with the connected routes, there is also a static information that we have added. S represents that it is a static route. See? So static information is added for 210.2.0, which is reachable via 210.3.2, which is basically router 2. Sayyid, we don't have any PC connected on 210.3.0, right? So we don't need DHCP for that. Now it's finally time for verification. So I'll go to my PC3 and I will try to ping my PC5. So I'll ping 210.5 dot, sorry, 2.2. First packet got dropped. Second also got dropped, but I got the reply for third and fourth. Why did we had to like drop the first two packets? For which protocol does this drops? R. Awesome. And later we got the reply, so we can see that this network is now connected to this one. Let me know what questions or doubts do we have. Michael, you will have to find out the IP of the next router, which you can check by using show IP interface brief command on the particular router. In real life also, you will be creating a network design where you can know basically what devices are connected to me. Yes, Ankush, you have understood it correctly. DHCP relay, I'll talk about that later on. As of now, we are focusing at static routing. So I want you guys to practice that first. Sure, here is a quick summarization to what we did. Basically, what we tried to doing is basically we wanted 210 1.0 devices to speak with 210 2.0 devices. So on R1, we had to install the information about this network, and on R2, I had to install information about this network. For this, we are using static routing right now. I told my router number one that there is a network 210 2.0 having 255.255.255.0 as the subnet mask. This can be reached via the next hop 210 3.2, which is my router 2. So if something needs to be delivered, I'll just open my pen 1 second. Yeah, if something needs to be delivered to this network, I informed R1 that give your packet to R2. Similarly, R2 is also informed that if something needs to be delivered to this network, then give your packet to R1. Now, when my PC 0, when my PC 3 wanted to communicate with PC 5, it will generate a packet, right? Source IP and destination IP. Then there will be source MAC and there will be destination MAC, correct? Source IP will be my own IP address. Destination IP will be PC5's IP. Source MAC will be my MAC address. Destination MAC will be my gateway's MAC address, right? So I will give this packet having destination PC5 to my gateway. There, my gateway will check the destination IP and will find out what is the destination. Destination is 210 2.2. R1 was informed that destination network 210 2.0 can be reached via 210 3.2. So it knows that if there is a packet which is supposed to be delivered to this network, then I am supposed to give it to 210 3.2. That means what R1 will do, R1 will simply give that packet to 210 3.2, which is my router 2. Now router 2 will also check its routing table. We'll try to find out where is 210 2.0 network connected. So it will check the routing table, and what will it find out? It will find out that 210 2.0 network is connected to me only. It's connected directly to me. On which interface? On FA0/1. So it will ask that who is 210 2.2. My PC5 will reply back with the ARP reply, and my router will forward the packet which it received from PC3 to my PC5. Make sense? And similarly, the whole reply thing will come back to PC3. In this particular topology, we have three networks. This first network, this is my second network, this is my third network. Do we have any other questions? Perfect. So I have pasted the lab guide already. You can see the pinned message and can get started with the lab part. Try out the lab by yourself and let me know once you're done. If it is in two different IP subnets, then also Ravi, we will have to add both the IP subnets in the routing table by using two static route commands. We'll look at more examples, guys, but first try out this one. Ravi, no need to get confused bringing a lot many technologies into the scenario. VLAN is something we haven't yet discussed. So we'll speak about that later on. We'll talk about it at that time. Sayed, please check the pinned message. I have pinned the message in the group. That's your lab guide for static IP routing. You can see the command there. So that's great, Anuj. If you have practiced it with 4 routers, that's amazing. Those who are doing it for the first time, keep it simple. Just put 2 routers like I have shown you here and follow the lab guide. Also, I will quickly give you an overview how you can access your lab guides. So this is our Telegram group, right? First of all, you can see here the message is pinned. If you click on that, you will get to the message which I was talking about, the lab guide for static routing. And for the earlier shared lab guides, click on the group name and just click on files. You will see all the files that I have shared in the history, right? So the day notes, the lab guides, all of that. So guys, please access it like this. Yes, Abhishek, these two devices needs to be on the same network. Otherwise, the in static routing will not work. Yes, Lion, if you have configured interfaces on some IP network, then it will be connected to a different network. I mean, they'll be considered as separate networks. Ravi, we require a layer 3 device. If we have a layer 3 switch, then yes, otherwise no. Guys, for the network 210.3.0, we don't need a DHCP pool because there is no end devices connected here, right? This network is just used for router 1 and router 2 to communicate with each other. Yes, Michael, a slash 30 network is more appropriate to connect such routers together. Gradually, I mean, we'll be introducing such things as well into the discussions so that we can all understand how it works in real life. As of now, I wanted it to be very simple and easy for you guys to understand. That's why we have kept it slash 24. And a great suggestion from Anuj. First, you note down all the networks and then you check which networks are directly connected, which networks you are supposed to add. Then, like I know on router 1, I have to add 210.2.0. Start adding it one by one. There can be one network, there can be five network depending upon the topology. So when you create a note of it, you will be able to do it very easily. Guys, switch do not care what network it is. It is a layer 2 device. We have to understand this. It's a layer 2 device simply connecting multiple devices together. So they really don't care what is your IP, what is your network. Okay. Awesome. Perfect. I can see some of you are done. And let's continue. Let's look ahead with one more example. How static routing can be configured in a given situation. This time we will add one more router into the scenario. So we'll take three routers this time. Router 1, router 2, and router 3. Similarly, I'll take three switches, switch 1, switch 2, switch 3, and some end devices. Okay. Then let's connect these devices together like this and like this and like this. Now by default on 2811 router, we will find only two interfaces. Okay. I am using the last router, 2811 router. By default, there are two interfaces on it. So for my middle router, I have utilized both my interfaces. I will not be able to connect cable now. The cable cannot be connected to that port. So what to do to fix this problem? Click on the router, shut down the router, turn it off, and add two fast Ethernet ports using this module NM2FE. How do you install it? I'll show you again. Click on NM2FE and drag it like this. When you will leave it there, it will get installed. Then you can start your router again, and then you can try to connect cable again. And this time you can see cable got connected successfully. Clear, guys? NM2FE. FE stands for Fast Ethernet. Now it's time to begin the configuration. So I will use three networks for local area networks or the local area devices. First one is going to be 192.168.1.0/24. This will be 192.168.2.0/24. And this will be 192.168.3.0/24. Between my first router, which I'll consider as R1, and R2 and R3. Here I will use the network 192.168.4.0/30. If I am using /30, that means how many IP addresses will I get out of it? Two IP addresses. So one for router 1 and one for the router 2. Yes, in total there will be four, but the usable IPs are going to be two. Correct? Similarly, for my router 2 to router 3 also, I will use a /30 network, so that the remaining part of the network can be used somewhere else, right? Maybe to fulfill some other requirements. Then it's time to begin the configs. So let's get started. I will go to router number 1. I'll say no to the question. Enable configure terminal. Host name R1. Interface FA0/0. IP address 192.168.1.1. 255.255.255.0. No shutdown, exit. Then interface FA0/1, IP address 192.168.4.1. What should be the subnet mask for /30? 255, 255, 255, 252. No shutdown, exit. We have configured router 1 successfully. Let's go to router 2. CLI, no to the question, enable config T, host name R2, interface FA0/0, IP address 192.168.2.1/24. No shutdown, exit. Interface FA0/1, IP address 192.168.4.2, 255, 255, 255, 252. No shutdown, exit. And then interface FA1/0 with the IP address 192.168.5.1, 255, 255, 255, 252. No shutdown, exit. Then I'll go to my final router, router number 3, CLI. No. Enable config T, host name R3, FA0/1, IP address 5.2/30 subnet. No shutdown, exit. Interface FA0/0, IP address 192.168.3.1, 255, 255, 2550. No shutdown, exit. Clear, guys? Now it's time to create DHCP pools. So I will need one DHCP pool for 192.168.1.0, one for 192.168.2.0, and one for 192.168.3.0. Okay. We will be looking at a DHCP relay situation here. DHCP relay means that all of my DHCP configurations are placed on a single server. And from that server, the information is relayed to the required networks. Okay. For example, in this scenario, I will create all of my DHCP pools on R1. So I'll go to my R1 and I will configure DHCP pools here. IP DHCP pool A for the first network 192.168.1.0/24 with the gateway address as 192.168.1.1. Exit. Then IP DHCP pool B for the network 192.168.2.0/24 with a gateway address as 2.1. Exit. Then finally DHCP pool C for the network 3.0/24 with a gateway address as 3.1. We have simply created all the DHCP pools on my router number 1. But guys, I need to also inform R2 and R3 that when they receive DHCP discover message, then they have to reach out to R1 for basically the IP address configs. Do you agree? Like R2 and R3 also must know that they should reach out to router number 1 for their IP address requirements. Yes or no? Yeah. So let's configure R2 and R3. On R2, I will go to the interface FA0/0. As there, we will receive the DHCP discover messages and type down the command IP helper address and IP of my router number 1. What's the IP of my router number 1, guys? One 192.168.4.1. Correct? Exit. Similarly, on R3, I will go to the interface FA00 as that is the one connected to end devices and type down that my IP helper is 192.168.4.1 exit. Now the final job is to configure static routing. For configuring static routing, we need to figure out how many indirectly connected networks are there for the router number 1. Okay. For router number 1, I can say 1.0 and 4.0 are directly connected. Yes? Yes or no? Perfect. So how many networks do I need to add? Let's figure out. I need to add 192.168.2.0. This one. I need to add 192.168.3.0. And I need to add 192.168.5.0. So let's do it. I'll go to my router number 1 and I will start adding these networks. IP route 192.168.2.0, 255.255.255.0. What will be my next hop IP, guys? It's going to be 4.2, which is basically the IP address of my router 2. So from router 1, if I want to reach 2.0, this network, then I need to give packet to router 2. So I will say this is reachable via 192.168.4.2. Enter. Okay. So we are done with adding 2.0. Now it's time to add, let's say 5.0. So IP route 192.168.5.0. What should be the next hop IP, guys? Same 192.168.4.2. Correct? No. No, Tarun, try to understand. Even if I want to give traffic to this network, then also R1 will give it to R2 only. Correct? So that's why next hop will be 192.168.4.2. Then finally, 192.168.3.0. Now tell me what should be the next hop. Still same, perfect. So even if I have to give it to this network, then also R1 will give it to R2 only, right? R2 might forward it to R3. That's a different case. But yeah, for R1, the next hop will always remain R2. So I'll type down the same IP 192.168.4.2. And we are done. Okay. Then time for R3 now. For R3, I have two directly connected networks. 192.168.5.0, 192.168.3.0. How many are the indirectly connected networks that I need to add? 2.0, 4.0, and 1.0. For all of them, the next hop will be this router only. That means 5.1. So let's quickly add the static routes on R3 as well. I'll go to R3 and let's configure static routes. IP route 192.168.2.0/24 with the next hop address as 192.168.5.1. Then IP route 192.168.1.0/24 with the next hop address as 192.168.5.1. Then IP route 192.168.4.0 with the next hop as 5.1. We have added static routes on R3 as well. Now it's time for R2. For R2, I just have two indirectly connected networks, as this is my directly connected network. Yeah. So for R2, yeah, I was saying for R2, we have 4.0 as a directly connected network, right? 2.0 as a directly connected network, 5.0 as a directly connected network. The only indirectly connected networks for R2 are 192.168.1.0, 192.168 3.0. Correct? For reaching 192.168.1.0, my next hop will be R1. Right? For reaching 192.168 3.0, my next hop will be R3. So I have to be cautious while giving the static routing here on my middle router. Okay. So I'll go to my middle router. I'll add IP route 192.168.1.0. Let me know what should be the next hop, guys. It's going to be 4.1, right? So 192.168 4.1. Then IP route 192.168 3.0. What should be the next hop? 5.2, which is router 3. And guys, we are done. Finally, we can try using DHCP on all these devices. Perfect. I got the IP. Desktop IP DHCP. I got the IP. I'll go to the next PC, PC9, desktop IP DHCP. My PC9 will give the request to FA00, and because it is configured with the IP helper command, it will forward it to 4.1. Okay. So sometimes it might fail. You can retry. As we have just configured routing, it might take a little time, right? And after I retried, we can see the IP got assigned. Next PC, PC10, desktop IP, DHCP. There you go. We got the IP. PC11, desktop IP, DHCP. It failed, but I'll try again. Because I'm making communication for the first time, it might fail for the first time. So yeah, now it is up. The IP is assigned to all the devices. Finally, I will go to my PC7 and I will try to ping all the other devices. First, I'll ping 2.2. I'm getting my replies. Next, I'll ping 2.3. We got the replies. Then I'll ping 3.2. We got the replies. And finally, 3.3. The replies are there. This is how the static routing can be configured for all the three devices that we have here in the topology. And along with that, we have looked at how IP DHCP relay can be configured. I'll show you the running configuration for R1. So on R1, you have to first configure IP addresses on your interfaces. Let me put it in the chat of Telegram. So router 1 configs will be first interface configs. Then after that, we created DHCP pools. We created these three DHCP pools. So I'll copy that also. And then we added some static routes. which are basically these three static routes. Then for router 2, if I check my configs, show running config, these are the interface configs. And static routes which we added are these two. Then finally, for my router 3, these are the interface configs. And the static routes that we added are these three. And let me also put a screenshot of the topology so that you guys can practice the same as per your convenience. Guys, do let me know if there is any sort of doubts, queries regarding static routing. I'll be more than happy to help you out. The IP helper command that we have added, it's for using DHCP relay only. DHCP relay means that you configure it on one device and you relay that information to the other devices. Just like there is relay race, right? You pass it on, right? Just like that, DHCP relay means you forward it to the other devices. Any other questions? Anuj, I have pasted the command in the chat that I have shared, and it has added on the LAN interface. So for router 2, because I wanted to tell R2 that they are supposed to take help from R1, I have to go into FA00, which is my LAN interface, the one interface which is connected to the LAN network. And there I added IP helper address, as you can see here. IP helper address, and then the IP of my router number 1, where my DHCP pools are created. Here, DHCP relay is a process, guys. It's not a device. R1 is playing the role of DHCP server. Pooja, we configured two types of password. For enable password, there were two types of password, uh, normal password and the secret password. And the other type that we looked at was the login password for Telnet specifically. Any other questions? All right, then I'm hoping that you guys enjoyed the class today as well. And with that, we are good for the day. I will introduce you guys tomorrow to dynamic routing as well as default routing. So make sure you practice static routing as much as you can. And I'm always there on the group available to help you out with your questions. So feel free to ask your doubts and queries anytime. Thank you guys. Bye bye. Take care. Enjoy your day. See you tomorrow at the same time.